4 hours. All right, good morning. This is it, right? Last hurrah. Let me just put up on the board real quick, just so it's, again, officially stated when the final is, all that stuff. And then we'll start doing the review, or answering questions over the review. So our final is Thursday, May 11th. Uh, 9 a.m. to 11:45 a.m. We have no class next Tuesday. And that goes for all of your classes next week. You should only be meeting one time. That way there's no overlap. Any questions? All right. Please be here on time, because you'll have this amount of time, but nothing more. So also, in terms of office hours next week, I will not have normal office hours because I will be giving finals when I would normally be in office hours. So I'll send out something hopefully the next day or so to let you know when I will be available next week. Since your exam is on Thursday, it actually might be useful to you if you want to come in and ask any questions. What else? What can you bring to the exam? Normal stuff, right? You have your formula sheets, right? And then I feel nice today. Let's say you can have one reference sheet that you can create, all right? And it can have any formulas, steps, procedures on how to do things, but it cannot have worked out problems, all right? That makes sense? Front and back, all right? Front and back. If you want to type something up, you can type it. If you want to copy, paste, and print from some other source, that's fine. Just make sure that you don't put anything worked out, all right? If you want to use some weird, like hieroglyphic stuff that only you understand, that's fine, but just don't work out problems and have them on there, all right? Any questions on that? Okay, so I wanted to answer questions over the review. In terms of work, I think I've put in all of the grades with the exception of the bonus problem where you have the surface area of the can. That I have not put in. Other than that, I believe I have put everything else in. So your grades online should be pretty accurate. I do have some old stuff here, so I'm going to pass this around. And when I pass around, you can't see grades, so don't worry about other people seeing your grades. I'll just pass this stack around. Let's see if there's anything else in here that you shouldn't see that has grades on it. All right, so there's not a ton of stuff. Just make sure you don't have anything in there. All right, and then I have some older stuff I can pass back at the end. All right, so questions off this review. I know I had one in particular that I was asked about online. So let me start with that one. And it's a good question because we didn't really do a problem like this in class. So it was number 12 off the review. Let me make sure I'm on camera here. Hold on. Everybody has the review, right? I think I don't have any more copies with me. Let's see, where am I? So all right, so number 12, it says y is equal to x plus 3 to the 4th power square root of 4 minus x over 4x minus 10 to the 7th power. And it's asking us to find the derivative of this, right? Find the derivative. So one thing we could do is the quotient rule, which would be a mess, right? This would be a complete disaster with quotient rule because you'd have to do derivative of the top, which is a product rule, but then you have chain rule. It's just, it's messy. If you've tried this problem, it's a mess. So I want to show you something, which is good that you're here, because this is going to make life a lot easier for you, all right? Notice that this problem is after number 11. And if you look at number 11, 11 is this problem, sine x to the x, right? Can anyone tell me what technique we would use to do this one? If I want to find the derivative? You do the natural log on both sides. Now, what tells you to do that? The fact that you have x's here and here in both places. So this is where we use what's called logarithmic differentiation. Maybe we should do this one first. Let's do this one, and then you'll see how we can use that over here. So let's do 11 next to this. You have y equals sine x to the x. So again, because, and I just said you could have a reference sheet, right? So one thing you could put on your reference sheet is, hey, if you're asked to find the derivative, and x's appear both in the base and the exponent, then use logarithmic differentiation, right? And then you could even say, what is logarithmic differentiation? Take the natural log on both sides, right? That would be the first step. Take the natural log on both sides. Oops. Hold on a second. All right. I've been getting so much spam lately, I don't know what is going on. So natural log on both sides, right? And then what? What's the whole point of that? Yeah, you can drop the x out now. Okay, the whole point of this was now we can drop this x out in front. So we get natural log y equals x times natural log of sine x. And now at this point, you no longer have that power up there that you have to worry about. So you can do a derivative at this point, and we'll just have a product rule. But you have to take derivative of both sides of the equation. So on the left side, you have to use a chain rule. So derivative of natural log of something is 1 over that something times now the derivative of what was inside, which is dy dx, because we're differentiating with respect to x on both sides. You could use y prime here if you don't want to use dy dx. You could just put y prime. Those two things mean the same thing. On the right side, I take product rule, right? So derivative of the first one is x, derivative of the second, times the second one, plus the derivative of the second one, derivative of sine is cosine, times the first one, x. So that's your product rule on the right. And we're almost done, except we're trying to solve for dy dx, right? So we need to get rid of this 1 over y. So what do? Multiply both sides by y, right? So if I multiply the left side by y, and the right side by y. And because there's two terms here, you must put this in parentheses because this y would distribute to both, right? So here we just get dy dx. And over here, 1 times that's just that. And then this right here, I'm just going to slide that x out front because it looks better that way. Put the x in front of the cosine x. And then lastly, when I have y here, I need to write down what is y, right? Because I want my answer in terms of x. So I go back and I look at the very beginning, y is sine x raised to the x. So right here, I'm going to put in parentheses, sine x raised to the x. That is the derivative of that function. Any questions there? Does it look familiar? No questions? I'm seeing some looks like, what's wrong?
So the log of sine isn't it like 1 over sine?
Wait a minute, what did I do? Oh man. Okay, let me have a little reset there. I'm having a day. Something's going on with me. I'm not sure what it is. It's been the last 2 days. I'm not here. It's really weird. I'm not worried about it yet, but if it continues, I'm going to get worried. Yeah, so what did I do? I did derivative of x, 1, write this down, plus now derivative of this. I don't know why, I just looked at that. I didn't do the natural log. I have to do derivative natural log of this, which would be 1 over it times what? Times the derivative of sine, which would be cosine. So what am I missing here? Right in here? 1 over sine x. And so that sine x is on the bottom. I'm just going to put it right here and fix it. Okay. That's okay now. All right. Hopefully things get better here. The method's the important thing, right? The method, the natural log on both sides. So, can I move on? On this one, we do not have that form of x is here and x is here, right? We don't have that over here. We just have an ugly expression. But what we do have is a bunch of multiplication, like I have a multiplication there and I have a division. And there are properties of logs back when we first were talking about logs back in the beginning of chapter 3, 3.1 and 3.2. I put all these properties of logs up from college algebra. So I'd like to state a few of those properties here. We know that the natural log of two things being multiplied is the same as breaking it into two logs with addition between them. This is a property from college algebra. And we also know that when you do the natural log of division, that you can break it into two logs with subtraction. Do you all recall this formulas? These formulas? These are properties of logarithms. So this says anytime I have a product in a log, I can split it into two logs, or division in a single log, I can split it into two logs with subtraction. I'm actually going to use that over here, but I need to have a log first, all right? So if I take, just like I did here, the natural log on both sides of the equation, this is going to be ugly. Okay, that's just taking natural log on both sides, right? Now on the right side, you can't drop anything down. There's nothing to pull out front. But what you can do is you can use this property right here that allows you to turn any division you see into two logs with subtraction, right? So I'm going to look at the entire numerator and entire denominator as my fraction. And so this is going to turn into two logs, right? The first one will have the numerator in it. The second one will have the denominator. So let's just do that first. So in the numerator, I had the x plus 3 to the fourth, and I had square root of 4 minus x, right? That's what was in the numerator. So that goes in one log. And then I'm going to say minus natural log of 4x minus 10 to the seventh. That goes in the second log. All right, do you all have any questions about how I'm using that property to rewrite that? Is that clear to everyone? Yeah? Okay. Now, once I'm here, I have to realize that I can use this property, this top one, because I actually have multiplication right here. And this one I don't have the multiplication. So it's just on that first property. The first natural log. Do you see that I can split that into two logs? Yeah? So I will have equals, not equals. I have a left side of the equation, natural log y equals, now, natural log of x plus 3 to the fourth power plus, right, because this formula says I'm going to split it into two with a plus between them, natural log of the square root of 4 minus x. And then I still have this one, minus natural log of 4x minus 10 to the 7. Do y'all see that? Now I have 3 separate logs, right? 3 separate logarithms. And for each one of these, I can use that property where the power comes out front. I'm allowed to do that now, okay? Because I have something to a power. This 4 can come here. I have this to a power. That 7 can come out front. And this is actually a power, isn't it? I can look at this as being 4 minus x to what power? The half power, right? So I can rewrite this as 4 minus x to the 1/2, right? So now let's drop all these powers down. Natural log y equals 4 comes out front times natural log of x plus 3 plus, okay, the half comes down, right? This half comes down. And then natural log of 4 minus x. And then I have to erase this. Minus 7 comes down, natural log of 4x minus 10. Still good? Now we have finally gotten to the point we can take a derivative now. And the reason I'm going to do the derivative now is because if I try and take the derivative of the right-hand side, I can do constant comes for the ride, take the derivative of natural log of something, constant comes for the ride, take derivative of natural log of something, constant comes for the ride, take derivative of natural log of something. You see how it's all going to be nice now? On the left side, I still have to do the differentiation on both sides. So on the left, I'm still going to have 1 over y times dy dx. Okay, that's derivative of the left side, equals, now 4 comes for the ride. What is the derivative of this? That's kind of like what I just messed up a second ago, right, with natural log of sine x. So you do 1 over what's in there first, right? 1 over what's in there, x plus 3, times the derivative of what's in here. What's the derivative of what's in there? 1, right? So I don't really need anything next to it, do I? So I'm not going to put anything. Plus the half comes for the ride. And now I have another natural log. So I take derivative of that. Derivative of that's 1 over what's inside. Be careful here. What's the derivative of what's inside? Negative 1. Right? Derivative of that is negative 1. So I need to put a negative 1 next to this. And then finally, minus the 7 comes for the ride times, okay, derivative of natural log of that is 1 over 4x plus 10, or sorry, minus 10. And then the derivative of what's inside. What's derivative of what's inside? I can't say derivative today. 4, right? Derivative of here is 4. And now that equals dy dx, right? So this, I'm just going to here move the 4 up top. 4 over x plus 3. Over here, I have the 1/2 in front, right? And I have a negative 1 that need to multiply together. That'll give me, I can write it like this, minus 1/2 times 1 over 4 minus x. So all that happened there is that plus became minus because of that negative 1. And then over here, the 7 and the 4 can come together and become a 28. And actually, I can put that on top. Right? I can put the 28 on top of this fraction. So 28 over 4x minus 10. Right? But okay, what happened over here? I just wrote dy dx. I multiply both sides by y. So I need all of this times y, right? Times y. What's y? That big ugly thing. Right? This is a y right here. So I have to multiply that all by this. So this is going to be x plus 3 to the 4th square root of 4 minus x all over 4x minus 10 to the 7th. That's it. So I did not do one of those in class. I think it was just a matter of time. But it's on the review, so I wanted to work it out. I would say on the exam, I will, I'll consider putting that on the exam as a bonus problem, only because we've only done one problem. If you go back to your homework for this section, no one has a book, right? No one has a physical book. In this section for implicit differentiation, if you go to that section, there's a few problems like this if you want to practice, all right? It would be right next to the problems that have like sine x to the x, right? There's a few problems like that. And in my homework solution videos, there should be some videos showing me doing a couple of these, all right? Okay, so even though that's not officially going to be on the exam, I wanted to at least show it to you and then make it worth your time, treat it like a bonus problem. With that out of the way, what else do we have on this review? Anything else that you looked at and were like, 7 on the first one? Okay. So what, on this problem we just did, what is it that you think would tip you off to use this method in hindsight? Right, this is the thing we were trying to take derivative of, right? In hindsight, all the what?
All the exponents.
All the exponents, right? This is to the 4th, to the 7th, this is to the half, and you have products in division. So whenever you have a bunch of products in division and things to powers, you start thinking, okay, I can use logarithms to start splitting that up. All right? All right, number 7, right? So number 7, another implicit differentiation. All right, so 7 cosine xy equals x minus y squared, and I'm asking you to find y prime. So you cannot solve this equation for y. If you try to, it's impossible to get y by itself and have nothing but x's on the other side. You can solve for y, but if you get y by itself, you're guaranteed have to have some y's on the other side. So this is an implicit equation, so we're going to use implicit differentiation, which means I'm going to take the derivative with respect to x on both sides of this equation. So when we say y prime, right, we really mean dy dx. So I take derivative with respect to x on both sides. Oops, I'm missing a parentheses here. All right. On the left side, we have chain rule, right? You have to take derivative of cosine first, which is negative sine, of whatever was in there, right? So you've done the outer layer. Now you have to take derivative of what was inside. And when I take derivative of what's inside here, I see a product. So I have to do a product rule, right? And when I do a product rule, I'm going to do, derivative of the first one times the second plus derivative of the second times the first. All of that needs to be in parentheses because this is going to multiply times that. So might be worth it for you to put like a set of parentheses now so you don't forget it. And now here comes my product rule. Derivative of the first one is 1 because I'm differentiating x with respect to x. So I get dx, that's just 1 times y. Plus, now I take derivative of the second one, derivative of y with respect to x is not 1, right? That's dy dx, which is what we're solving for. So dy dx times x. That finishes the product rule, and therefore finishes the chain rule, right, that we were in the middle of. Questions there? We're done on the left. On the right-hand side, equals Derivative of x, I can do these separately because they're subtraction. So derivative of x is 1 with respect to x, minus now the derivative of y squared. It's not just 2y, right? There's a little bit more to it, right? Because you do the 2y first because the 2 comes down, right? 2y to the first power, right? But then you have to go in and take derivative of the base, the derivative of y itself, which is dy dx again. Questions? All right, so this is the derivative, right? That's like kind of like a raw derivative. But I actually want to know what dy dx is, which means I want you to actually solve for dy dx. Get dy dx equals some answer. And this is really a part that students struggle with, especially if you forget to put this parentheses. Because in order to get dy dx free from this parentheses, you must distribute this negative sign of xy through to both of these terms. That's the only way to get that dy dx out on the left side. So let me do that. Got to multiply here and here. So watch the way I write this. This is really just y, right? That's just y. So y times that, I'm going to write negative y sine xy. I just put the y in front. And then I have, let's see, positive this times negative that. That's going to give me a negative. I'm going to put the dy dx in front, the x next to it, and then the sine of xy next to that. It really doesn't matter what order you put these in, but normally we put the trig function at the end. So that's distribution through the second term. And on the right-hand side of this equation, I'm not touching it yet. Just going to leave it alone. See, no more parentheses. This term right here that has dy dx in it, oh my goodness. This term right here that has dy dx is completely free now. I can move it around, right? I can move it to the other side of the equation, do whatever I want. And then over here I have another term with dy dx. So the method is to try and get everything with dy dx onto one side of the equation, everything that does not have dy dx to the other side. And the side that you go to doesn't matter. It's your choice. So which side would y'all like the dy dx on, left side or right side? What's that? Right side? Okay, so if you're going to move your dy dx's to the right, that means this one has to go that way, which means you're going to add that, right? This right here, you're going to add it to this side to make it go away, and then you're going to add that over here as well, right? Also, this does not have dy dx in it, right? So I need to get rid of it on the right-hand side and make it appear over there. So I'm going to subtract 1 here, and over here I'll have to subtract 1 as well. All right? So I should have on the left side, because I subtracted 1, I do minus 1. And then I still had over there minus y sine xy. And then on the right side, let's see, what's over here? I had the negative 2y dy dx. And then I moved this, which was negative over here, I moved it to the other side, which made it appear over here positive. So positive dy dx y, oh no, not y, x, sorry, x sine xy. Everybody following me? Why did I do that? Why did I get all my dy dx's to one side? What's my next step? What's the whole point of that? Pull out the dy dx, factor it out, right? That's the whole idea here, is that the right-hand side, both terms have dy dx, so I can factor it out like a GCF. On the left-hand side, I'm going to move down here. On the left-hand side, I have negative 1 minus y sine xy equals, pull the dy dx out as a GCF. That would leave you with a negative 2y, and it will leave me with a plus x sine xy. So I just pulled out this GCF, right, from both terms. One more step, right? One more step and we have dy dx by itself. What is it? Divide by everything here on both sides of the equation. So on the left-hand side of the equation, I take -1 minus y sine xy, and I divide that by this expression here, -y plus x sine xy equals dy dx. And we're done. Okay. Any questions? What's next? We did 7. We did 11 and 12. What else would you like to go over? Number 8? So number 8, the volume of a cube is increasing at a constant rate of 20 cubic centimeters per second. How fast is the edge of the cube increasing when the length of the edge is 10 centimeters? What type of problem is this? Related rate. Good. Related rate. So this is where you had that little sheet that I gave you that you could use as a template where we draw pictures and stuff. You're free to have that on the test. I won't provide it, but if you have some blank ones, you can bring those. All right, so I'm going to draw a picture here. We have a cube, right? So you have to know what a cube looks like. The fact that I say cube means all sides have the same length, right? All sides have the same length. So in my general picture, this is x, this is x, this is x. I don't know what they are, but I know that for sure. I'm given that the volume of the cube is increasing at a constant rate, right? The volume is increasing. Increasing at a constant rate means that's the derivative, the rate of change of something. So what is the 20 for us? The 20 cubic centimeters, what is that? The change in what? Volume. So I'm going to write that as dv dt, right? That's given to me. Given the rate of change of the volume. What do I want? How fast is the what? Edge of the cube increasing. Well, what are we calling the edge of a cube? X, right? So I want to know how fast x is changing with respect to time, right? But I have to tell you when I want that. I want that at exactly when the length of an edge is 10 centimeters. So what does that mean? When what's 10 centimeters? When x is 10, right? At x equals 10 centimeters.